2022, and our first event of the year, as Leslie said, hooray. So we have a really special guest today. And before we get started, I just wanted to maybe jar Ralph's memory a little bit, and had to jar mine to think back on this about the first time I met Ralph. And dates back to 2009 at my very first Las Vegas show event. That's when the show was still held at the combo Alexis Park and Saint-Tropez. And I think, Ralph, you were in one of the Saint-Tropez rooms. And I stopped in the room. I think the setup had classic speakers and some of your, obviously, your equipment. And I thought, you know, the takeaway from that day was just being able to sit around with you and listen to Porcupine Tree and hang out and listen to some good music and, you know, enjoy the rest of the show just with that in mind. But over the years, I've, you know, I acquired some Atma-Sphere equipment. I still have it, use it, and enjoy it. And, you know, I think today's discussion will really kind of, if you don't know Ralph, will be a really enlightening discussion on, you know, who he is, what he does, how he does it, and some of the cool things he's got coming out with right now. So I'm going to just stop there, and I'm going to introduce you all to Ralph Karsten of Atma-Sphere. And Ralph, if you'd be so kind, I think some of us probably know you already or have heard of you, but maybe you can tell us a little bit about yourself and, you know, as a degreed engineer, why you chose to go down this road in your life's career path.
All right, so you're saying this thing is on, right?
This is on. You're on. Actually.
Okay. Yeah. I've always been interested in music. I think I had my first piano lesson when I was 3.5 years old, and didn't do much with it. But when I was in 6th grade, I took more lessons because my stepfather had built a harpsichord, and I wanted to be able to do something with it. So I did that, and I've played a variety of instruments, but long about high school, I started developing more of an interest in progressive rock and stuff like that. So I always wanted to be in a band and maybe record an album or something like that. Anyway, that continued on after high school, and the day after I graduated from high school, I got a job working at the Allied Radio Shack Service Department that was in Midway Center here in the Twin Cities, and it served a 5-state area of Wisconsin, Minnesota, North and South Dakota, and Iowa. And because Allied had everything, they had Kenwood, Pioneer, BSR, TIAC, all kinds of different stuff. I worked on all kinds of amps and receivers, tuners, tape decks, cassette machines, automotive stuff, just everything. So, you know, I could be working on shortwave receivers or police band scanners, or perhaps it was going to be a CB radio or some kind of tube power amp. You just, you know, it was the luck of the draw. And so that was a good experience, but I did well with it. But I wanted to further my education, and I used my job at Allied, it became Radio Shack actually shortly after, to put myself through college. And I went to the University of Minnesota and the Institute of Technology there. Anyway, long about 1978, I was still at, actually it was 76. I was still at Radio Shack at that point. And I remember I had been modifying a Stereo 70 for my stereo. And I was talking to a friend of mine about what was the possibility that you could do with a tube amplifier if you didn't have an output transformer, and if you could find a way to direct couple the tubes to the speaker. And I really didn't have any history grounding at that point. I didn't know about Futterman. or any of the prior art at that point. Of course, those days there was no internet, and I was kind of just toying with the idea, and I dozed off on the couch, and I had a rather peculiar dream. And in the dream, I saw this idea that I had been thinking about as I fell asleep. How could you put two opposing currents through the loudspeaker at the same time such that the current in the speaker would cancel unless there was an offset? And the offset would be, of course, your musical waveform. So, well, I woke up and drew the circuit down. And that was actually a circuit that had been around for a while, known as the circletron. But I came up with a few innovations. It was a bit of a struggle, but I wound up getting a patent in the area. And I started building amplifiers based on this concept, and playing them for audiophile friends of mine. And, boy, I think Peter Moncrief had written a review of some audio research amplifier that basically said, sell your wife's mink coat, you have to get this thing. That was kind of how I remember it. And it seems like that would be a grounds for divorce in some cases. But a friend of mine was able to get his hands on one of these amps, and we played it on a set of old Magnaplanar Timpani 1Us, which had a 7 ohm impedance. And we played it against this amp that I had built up out of surplus parts. And, I punched the holes in the chassis and just kind of put this thing together. And boy, you know what? It sounded more fluid, more organic, played bass better. It was more extended on top. It was faster. It was more three-dimensional. There was really nothing that the audio research did better. And I was surprised, and everyone else in the room was surprised. And at that point, I thought, you know what? Maybe this is a thing. And so I started pursuing it part-time for a while. And then, I started designing chassis and working with, I'd gotten some drafting in school. And so I started doing mechanical drawings, and I gave them to some local sheet metal people and produced some actual chassis. And we did a short run of amplifiers, and they worked. I took one over to a local audio store here in town, which is called House of High Fidelity. And it wasn't far from me. The guy that ran that was Paul Joaquin, who works with Still Points these days. And they thought that it sounded pretty decent. So I was able to work with them, and we sold a few amps through there. And it just started out as this very much a bootstrap operation, where it just was a word of mouth thing. I never had any real capitalization behind it. I'd spent all my money on college and buying my house and stuff. But that was where it started, and I built it up from just a maybe 1 or 2 amp sales in 3 or 4 months, something like that. And it turned into a deal where over time the business took over my house. So I was basically, I think my bedroom and the bathroom and the kitchen were the only rooms that didn't have something to do with the business in it. And finally, I bought another place, and because the house was actually starting to restrict the ability to do business. So anyway, it's taken off, but it's been a slow thing. One of the things I learned at working at Radio Shack is that some electronics are not built to be serviceable. And I found that to be really annoying. So I put in place some safeguards, is kind of how I looked at it. I designed for tubes that were in production. I designed for capacitor voltage values that I thought would still be in production 20 years later, something like that. I was pretty conservative about a lot of the design approaches so that I knew I could get parts later if I needed to service this stuff. And I designed it so that if it needed service, I could open it up and do the service fairly easily. And I think that's really helped us out. And the other thing that really helped us out is, I built this stuff because I wanted it to work in my living room and I wanted to be able to live with it. And so it was reliable. It held together. And the reliability is probably the thing that we really brought to the deal, because we had the world's first reliable OTL. Before us, the OTLs, more than perhaps digital versus analog, or tubes versus transistors, the prior art had convinced the world that OTLs blow up. So that was the thing that we really figured out. And it was a long haul, but I wasn't really interested in, I never got into the business to make money. I got into business because I thought, you know what, this is really cool. If you get the amp on the right speaker, we couldn't find anything that could beat it. And, it'd be more three-dimensional, faster, deeper bass, stuff like that. And that's just how we proceeded. So I think I did my first consumer electronics show in 1989. And, we've never been a large scale manufacturer. We've just continued on, and it's just been on this slow growth process for the last, I want to say, especially in the last 30 years.
So Ralph, we got a couple of things here that came through on the chat. I don't know, we all like to speak in acronyms sometimes, so maybe you can talk a little bit about OTL and the concept versus traditional designs. And also maybe a question you can touch on now or later, depends on how you want to approach it. But we have someone who's more interested in understanding from the aspect of amp or preamp, which one affects soundstage height, width, depth the most. So just a couple questions there.
Okay. Well, an OTL stands for output transformerless. There's a variety of other things it stands for, but basically what it means is it applies particularly to a tube amplifier that doesn't have an output transformer, as opposed to a solid state amp. Back in the early 1970s, OTL applied to solid state amps too, but that became so commonplace that really these days it means a tube amplifier. So anyway, the idea behind it is essentially that the output transformer is usually the bandwidth limitation in the amplifier. The output transformer is also going to introduce distortion of its own. So, theoretically, if you can eliminate the output transformer, you can have wider bandwidth and lower distortion. That's the basic idea. And in practice, OTLs tend, because there is no output transformer, quite often they tend to have a slightly higher output impedance than typical tube amplifiers. But if you have them on a speaker with which that is friendly to the amplifier, quite frequently you'll find that the additional transparency is immediately obvious. So that's been the thing that's kept us going, is that I would be very careful about vetting what speakers a customer would have, and then once they heard the amplifier, there's no going back. So as a result, we've been able to build a very loyal following over the last, I would say 30, 35 years in particular, because people just go, I've heard all these different amps and I keep coming back to this one because I love the transparency. I love the liquidity in the mid-range, and it just sounds more like real music, and that's what we're after. That's always been what we've been after. So if that sounds like a nutshell, that's what an OTL is.
You touched on something there regarding, the right speaker. So we had a question that came in like, well, what speakers work well with OTLs in your opinion? What are some of the things people should look for in the speaker design itself?
With regards to that, I do have an opinion about speakers that probably isn't popular with speaker manufacturers, but excuse me, I'll just put it this way. If you are investing in an amplifier, and I don't care if it's tube or solid state or Class D, your investment dollar is probably going to be best served with a higher impedance speaker, all other things being equal. If your interest is to get a little bit more sound pressure, there might be an argument for going with a lower impedance speaker if you have a solid state amp that can double power as the impedance is halved. But otherwise, what happens is your distortion is lower into a higher impedance speaker. And this is true of tube amps, this is true of solid state amps. And the thing is that lower distortion is audible in that if you can just somehow make the amplifier or the speaker be higher impedance, it'll immediately sound smoother and more detailed than it did before. And that's with any amp. So, this being high-end audio, where basically you do what needs to be done to achieve the goal, to me, I don't see where 4-ohm speakers or less has any place in high-end audio, because there is always a way to make the speaker higher impedance if the designer so sees fit. And there's a lot of speaker manufacturers probably don't want to hear that sort of thing, but I've been doing amplifiers now for 47 years straight, and you can see this in the specs of any amplifier made. And we'll put it another way. If you've got an amplifier and it has to work hard for a living, I don't care what kind of amp it is, it will have higher distortion, and that distortion will be audible as harshness and brightness, because it'll likely be higher ordered harmonics, and the ear uses those harmonics to sense sound pressure, and it assigns a tonality to them. And higher ordered harmonics are assigned the tonality of harsh and bright. And we've been hearing this for the last 50 years. I mean, that's why tubes are still in production. So, there's my diatribe. In other words, if you want an OTL to work with a speaker, your chances are better if the speaker is a higher impedance, 16 ohms as opposed to 8, and certainly 8 ohms as opposed to 4. We do make bigger OTLs that can drive 4-ohm loads, but frankly, they get exorbitant. So. Uh-oh, something happened to the sound here.
So in addition to amplifiers, you make preamplifiers too. And you also, and I apologize if this offends you, but I'm trying not to, but you kind of went full in on balanced technology.
We did, that's right. I played in an orchestra when I was in high school, and I got recruited by a local college, McAllister College, to play in their orchestra. And we were doing a concert, and I noticed a couple of Neumann microphones hanging from the ceiling. And I just followed the mic cables that went up into the cloud ceiling and down over to the recording booth. And I went and chatted with the recording engineer, whose name was Mike Shields. He's still around today. He let me listen to the direct microphone feed, and it was spectacular on the headphones, absolutely spectacular. And, that made a big impression on me. I knew coming out of high school that balanced lines work, that you don't need an exotic interconnect cable technology, that the balanced line system is the exotic interconnect cable technology that obviates the needs for particularly expensive cables and cables that work and sound musical. And that lesson has been something that every audio engineer knows, and this is going back all the way to the early 1950s. When you see audio engineers telling audiophiles, hey, cables don't make a difference, they're used to cables not making a difference in their world. Now, I knew Robert Fulton, who was the manufacturer of Fulton Musical Industries, which is a high-end speaker manufacturer here in the Twin Cities. And Robert Fulton had come out with his Fulton brown wire and his Fulton gold cable, which are speaker cables, but he also had an interconnect cable. And he could demonstrate that, yes, this here single-ended cable with gold clad ends on either end did sound better than the stuff that you bought off the wall at Radio Shack. And he's the guy that pretty much founded the high-end cable industry. He was there before Monster or anybody else. And so when I was being introduced to him was when I was being introduced to high-end audio in general, was through him and customers of his. And, you know, I saw that all of a sudden they're starting to spend money on interconnect cables. So in the late 80s, when I started designing, or it became evident that we had to have a preamp along with our amps, I started looking at, well, why not do this whole thing balanced line? Because if we do it balanced, we're going to get rid of this whole interconnect cable thing. We won't have to worry about that. And, you know, there'll just be all these advantages. And so that's what I did. I designed what wound up being the world's first balanced line preamplifier ever offered for home audio. And for that matter, all of our products were balanced at that point. We made the world's first balanced line stuff for home use. And the whole idea was transparency. Now, back in the old days, you know, when RCA was in the golden age of stereo, they were recording with an Ampex 351-2 tape machine, and it had transformer input for the microphones and a push-pull output transformer to drive the 600 ohm balanced line at the output of the tape machine. But we were the OTL guys at this point. And it turns out that the circlotron, if you have it balanced so that neither side is at ground of the speaker terminals, it's a balanced output. So, you know, what I did is I shrunk that circuit down so that we had it inside a preamp. I came up with a servo control circuit to take care of the DC offsets, and I got a patent on that. So we had a direct coupled vacuum tube output, no output transformer, and it could drive a balanced line, and it could be 100 feet long, and it was no problem. And so I started taking this thing around dealers, and they didn't want it. That was the worst thing ever, because how are you going to plug in the turntable? You know, you had to change the interconnect cable to do a demonstration, and they didn't like that. But, you know, cartridge is balanced source, and where better to have the interconnect cable be as neutral as possible than between the cartridge and the preamp. So we just kept pushing with it. Nowadays, people are very used to balanced line in audio, but we were the guys that introduced that to high-end audio. Audio Research, they made some attempts at balanced phono input and stuff like that early on. I think sometime in the 90s, and I just faxed them over. I forget who it was. It might have been Dave Gordon, who was the sales manager over there, asked me about it. And I just faxed him some pages from our owner's manual that shows how to do the connection for a balanced cartridge connection. And so Audio Research was an early supporter. So was Jeff Rowland, a few others, and it just took off from there. But you know, that's we were. I think I could say I'm more dedicated to using balanced line for home audio purposes than I am even to the idea of an OTL. So yeah, the preamp to me, I think, is a much bigger deal.
Another question that just popped in with reference to, preamp matching to power amplifiers. Can you speak to that a little bit? And then also, I think on top of what you just mentioned, you're talking about the cartridge as a balanced source. I mean, I play tape as well, and we've had conversations about the tape head also being a balanced source. The connections and how versus unbalanced, for example, the reference to ground itself. And maybe speak
Well,
to that a little bit.
let's take it one at a time here.
Yeah.
What was the first question again?
The first question was preamp matching to an amplifier.
Preamp. Well, in general, you want the output impedance of the preamp to be at 1/10 of what the input impedance of the amplifier is, and that's a general rule of thumb anywhere in electronic design. You want whatever is driving, whatever is the transmitter, to have an output impedance that's 1/10 of whatever it's driving. So in the case of our preamps, they're designed to drive a 600 ohm balanced line. And heck, the lowest impedance I've seen on any high-end audio power amps is 10 kilo ohms. So that's never a problem. But that's generally how you do it. Now, in a tube preamp in particular, the one thing you have to watch is that the output impedance is variable with frequency. And that's because in a tube preamp, there's usually a fairly large output coupling capacitor. And the output coupling cap has a timing constant that relates to whatever the value of the cap is versus what it's driving. And what it's driving is going to be probably the input impedance of the amplifier. Well, at 1 kilohertz, or pardon me, 1 kilohertz, you might have a certain output impedance, let's say it's 500 ohms. But at 20 cycles per second, that output impedance, even though the preamp has flat response, when it's measured on the bench, that output impedance could be considerably higher at 20 cycles per second. And this may result in a lack of bass. And so that's an issue. You basically, with a lot of tube preamps, the output impedance is a sort of U-shaped deal, and having entirely to do with the inductance of the capacitor at the high end and the impedance of the capacitor at the low end. So that's always something that's bugged me about tube preamps, and having a direct coupled output gets around that, because basically the frequency response of the output buffer of a direct coupled preamp is also its output impedance. They're exactly the same, curve. So if you can say, okay, the output impedance of this or the frequency response of the output buffer is from DC up to 400 kilohertz, there's your output impedance also. So I think it's a nice solution to get around that, but it's tricky getting a tube preamp to drive a direct coupled output. The solid state is fairly easy.
The question there was regarding talking about the cartridge or tape head as a balanced source, and also just within balanced design, the reference to ground versus an unbalanced design. Maybe you can talk a little bit about grounding and just how that's accomplished, noise reduction benefits, if any, or we had a little discussion about this on our happy hour Friday too. So it's kind of timely.
Okay. Well, first I want to put to bed a certain misconception. A balanced output does not have a center tap. Let's say you've got an output transformer, there's no center tap. So if you had a cartridge that was a balanced output, it would not have a center tap either. Are we clear on that? So what a balanced output is it basically means that at either side, the plus or minus output, or what you might say the inverting and non-inverting outputs, have equal impedance to ground. And that impedance might be 100 ohms, or it might be infinity. It's equal impedance to ground on both sides, okay? An output transformer is pretty close to infinity, okay? Very, very high impedance to ground, both sides, and it's equal. And so, what ground is that's the ground of this, maybe the circuit or the chassis, but it's not anything to do with the audio signal itself. So if you look at an output transformer, it just has a single, maybe a winding, and the signal comes off of that winding, and well, that's the winding of a cartridge is the same way. The winding of a tape head is the same way. Neither of them are referenced to ground. And in the case of a cartridge, if you look at it, it is the one rather peculiar single-ended source that seems to need that weird grounding wire. And that is because the ground wire is the ground shield system, which is the tone arm tube, the base of the tone arm and maybe the plinth of the turntable itself. That's what that is. And in no place in there is that signal wire from the cartridge in contact with the ground, neither side. That's a perfect example of a balanced source. So tape heads operate the same way, and dynamic microphones work that way as well. So anything where you have equal impedance to ground, neither side is at ground, that's a balanced source.
Then another question that just came in sort of on the same topic is, how do you integrate balanced to unbalanced? Do you tie to ground, or sorry, do you tie ground to low positive or lift?
Well, the way they do it in a phonograph is probably the best way to do it if you're going to take a balanced source and run it single-ended. Yeah, you're basically going to have to take the grounding system, tie that to chassis, and use the outputs, one shielding the other. That's probably the best way to do it, but frankly, the thing to understand is that single-ended and balanced are mutually incompatible systems. They absolutely do not have anything to do with each other. So you always have to jump through some hoops. Sometimes you can just ground one side and it's okay. If there's a transformer involved, you can probably do that. So, transformer coupled output from a preamp, the transformer's floating. If you tie one side to ground, you're good. But if it's a balanced output that is involving, say, balanced semiconductor output circuit, now you're tying one of those semiconductor outputs to ground. It may not like that. Bad things could happen. So if you're wondering what that barking is in the background, I have a dog that is just really hates to be alone here. And if you'll excuse me, I'm going to allow him into the living room, and that way he'll shut up. Okay, so hang on.
Fair enough.
He doesn't like to be cooped up. So he's probably just going to hang out with me, and I guess that'll be all right. So are we back on the air? Is this thing on?
We are.
Okay, good. So regarding the rest of it, one of the better ways to do conversion is using some kind of line transformer, that can convert from a single-ended source to balanced or vice versa. And transformers, any transformer has the ability to do that. Whether it's used that way or not is a different deal, but that is certainly the case. So for example, step-up transformer is used with a lot of low output moving coil cartridges. You can run balanced from the tone arm to the SUT, and then single-ended from there to the preamp if you want. The advantage of doing that is that if you run a balanced cable between the tone arm and the step-up transformer, that cable can be neutral. And boy, I've been watching people spend some serious cash on tone arm cables. It wouldn't surprise me that people that are watching this session here might have a tone arm cable that costs them $2,000 or $3,000. And there's really no need for that, because if you run it balanced, what becomes important is that it's constructed properly. And what has to be constructed is a twisted pair with a shield, and that you keep your capacitance low, perhaps 20 picofarads per foot, something in that area, and that cable will work. And as long as the input, whatever you're driving, if it's the input of a preamp or a step-up transformer, as long as it has a decent, what's called a common mode rejection ratio, which is the ability to reject noise that is applied to both inputs at the same time. So if there's a common signal to the plus and the minus, if it can reject that to a great degree and not amplify it, then you're golden. At that point, the cable will simply work. And I've always seen that as the lovely thing about balanced line audio. It's not, you know, I mean, I knew the guy that founded this, you know what I'm saying? The guy that started this whole thing, it was a single ended cable. When you go to balanced, you don't have to be playing that game. And I have to say that's one of the things that's I really surprised me when other manufacturers started jumping into the whole balanced operation. I started seeing a lot of products that didn't support the balanced line standard, and there's a number of tenets about that. One of them I've been already talking about is how ground is basically ignored. And I've seen a lot of manufacturers create products where essentially their outputs are two single-ended outputs, one out of phase with the other. And the ground return is how the signal is completed. Well, when you do that, now the construction of the cable becomes important. So, you know, I don't know. I found that to be disappointing that that sort of thing happened, but and I don't know if it's because manufacturers are basically ignoring the balance line standard, which is also known as Audio Engineering Society File 48, or if it's or if they just don't know about it. I've never tried to figure it out.
So I've owned your equipment for some time. I bought my first piece back in 2010 because I was using Duke Legern's audio kinesis speakers at the time. Really great speaker. It's probably one of my favorite of Duke speakers, and you know, smooth load, had everything you said. You know, should match up nicely with a OTL amp. And later on, I added the preamp and such. And I tend to use them together for a lot of the reasons that you talked about, just in support of the balance line standard and such. And you know, obviously the synergy between the products, the units are quite good. But what are your thoughts on, I guess, mixing and matching, not just maybe your components, but just mixing and matching in general, say a tube amp with the solid state pre or vice versa. You know, again, just kind of things people should look for, just thoughts, opinions, you know, in general, just kind of a chit chat question.
You know, I have to say my opinion about that's been changing over the last couple of years. But my feeling is if you're going to involve tubes in the system, but you don't want to have it throughout the system, put the tubes in the preamp and have a solid state amp. I think that gives you a better chance of things working out. Of course, you have to be careful with the preamp, that make sure that the preamp, its output impedance at 20 cycles per second is at least 1/10 or better of whatever the input impedance of the amp is. So if the amp has an input impedance of, say, 47,000 ohms, the output impedance at 20 cycles per second had better not exceed, you know, 4.75 K. And if you do that, then it'll play bass right and everything it'll work. I have a dilemma. We've been working on a project for about the last 5 years at Atma-Sphere, which is our Class D project that some of you have heard about. Now, I've maintained for many, many years, and if you go on our website, you'll see an article about this, that there are two different paradigms of the use of amplifiers in high-end audio. The predominant one is what I call the voltage paradigm. And the one that was there before that was developed is called the power paradigm. And how it works is that in the voltage paradigm, the speakers are said to be voltage driven, which is to say that the amp can double power as you cut the impedance in half. Everybody's heard about this. In the case of the power paradigm, what happens is the amp will try to put out constant power with respect to load. Now, back in the mid 50s, somewhere in that area, there were a good number of amp manufacturers that made amplifiers that had variable output impedance. They had a damping control on the amplifier that they could set it so that at one end the feedback allowed the amplifier to be constant voltage. At the middle of the control, Fisher made some of these in particular, they were constant power, and at the other end the amp behaved as a current source. So when it was a current source, its output impedance was very, very high, and when it was a voltage source, the output impedance was very, very low. Well, back before Electro Voice and Macintosh led the charge to developing the idea of the amp behaving as a voltage source, you know, this is one of the ways of dealing with it, but it wasn't necessarily plug and play. You'd buy a speaker, you'd plug it into the amp, and it wouldn't sound right. You'd have to go in the back of the speaker and adjust the mid-range and tweeter control to get everything to play properly. And I think a lot of people thought those controls were to adjust the speaker to the room, but that is not the case. It was to adjust the speaker to the voltage response of the amplifier. In other words, if the amp had a higher output impedance, you would set those level controls differently than if the amp had a low output impedance. The reason I'm bringing this up is that I felt in many ways that one of the problems that have been an epidemic in audio over the last 50 or 60 years is how feedback has been applied in amplifiers. Now, negative feedback is pretty common in solid state amps, but in tube amplifiers, you can design the amp to be fairly linear without feedback. And of course, a lot of the single-ended triode amps are an example of that. And our OTLs were too. What I found is that when I applied feedback to our OTLs, we couldn't get the soundstage to be as big and wide and deep, and we'd get some brightness on top. And it turns out some of that brightness was coming from distortion that was caused by the addition of the feedback. Feedback will introduce higher ordered harmonic distortion through the process of doubling whatever the input signal is. So if there's the input signal and it's got harmonics, it'll just double all that. And this will wind up being part of the noise floor of the amplifier, is this harmonic and inharmonic information and intermodulations that occur at the feedback node. And this occurs in any amplifier that's got feedback. Well, this is one of the reasons why feedback has got such a bad name, but what we're looking for, all of us are looking for, is neutrality. And I just felt that, okay, you know, let's just be pragmatic. If we're not going to have feedback, the output impedance of the amp is going to be high. You're going to have to adjust the speaker to the amplifier, or have a speaker that's outright designed for a high output impedance, like an Acoustic Research AR1. And that's just how you're going to have to achieve this, because if you can get the distortion down, your brain has a tipping point where it will pay more attention to the tonality caused by distortion than it will actual frequency response errors. And as we all know, all speakers have frequency response errors no matter how linearly you drive them. So this was what I was saying, is that, you know, you can get neutrality by having an amp with a high impedance if you're careful about your speaker choice. So when you take a solid state amplifier and it's got some brightness and harshness in it caused by the way its feedback loop is designed, you're going to have trouble getting to that neutrality. Some people will use the tube preamp to tone that down. You see where I'm going with this? And that's that's all right, but the thing is, if you take one a synergistic effect, this piece is bright, that piece is dull, and try to put them together to achieve neutrality, it doesn't work. You usually wind up with more distortion and more kind of peculiar colorations. And so I've tended to stay away from that as much as possible. I feel like I'm getting out in the weeds here with this, but my point is that, you know, if you have a solid state amp that's bright, I don't care how good your equipment is downstream, you're not going to be able to fix that. So you need to get everything right at the beginning. And, you know, so it really, what this comes down to more than whether you're using tubes or transistors is the piece really, in fact, neutral? And I'm just putting it out there that, you know, a lot of the solid state crowd is going, well, you know, tubes have that ever loving second harmonic. It makes it sounds all warm and everything. And yeah, it sounds nice, but it's not neutral. Well, harshness and brightness isn't neutral either. And that's the long and short of it. If you want a solid state amp that's truly neutral, it will not be harsh and bright. If you have a tube amplifier that makes a lot of second ordered harmonic and it's got a lot of warmth, it's not neutral either. So for the tube stuff, you've got to reduce those lower ordered harmonics without messing with the higher orders. With the transistors, you've got to somehow make the higher order stuff not be audible. And that either way, it's a bit of a trick. We've been evolving slowly from each direction towards a greater neutrality. And, you know, I think the older audiophiles here have been watching this happen for the last 40 years. So there's my complex answer to a relatively simple question.
Okay, so you touched on something earlier on there before you kind of got into the lengthier part of the response. Let's talk about that Class D amp. We have a lot of people in our group that have been using Class D amps for a while, different topologies. I know you've picked yours, so maybe you can talk a little bit about how you came to design it, what you chose as your topology. I think you were planning on showing us some pictures, and then while you're showing us the pictures, you can also maybe show us your system and talk a little bit about your system. Or not.
I'm not going to do pictures. I'm just going to show the actual stuff. Okay, regarding Class D, 20 years ago, I heard some Class D stuff. I heard a early bel canto amplifier, and I don't know if it was a prototype or not. I kind of suspect that it was, but it didn't strike me as something to take seriously at the time. I heard a bunch of other Class D amplifiers from that same period, and it seemed to me that you really couldn't take them seriously. About 5 years ago, I started hearing stuff that was like, oh boy, they have really made some major improvements. And one of the things I was hearing is that, you know, you don't hear the harshness and brightness out of these things in traditional solid state, although they do seem to have other colorations. For example, in the musical instrument world, Class D was taken over in bass guitars. But man, all the Class D amps I saw doing that, they couldn't play deep bass properly. You needed a more traditional amplifier to really make that happen. But anyway, they had gotten to the point where I thought, okay, you know what, we got to start taking this seriously. And I started researching it and messing around with stuff, and came up with some ideas, and we got a patent issued about 2 years ago. And we've been working on it ever since. And when I say we, it's a collaboration between me and one of my employees who is very adept at the mathematical side of it. There are some things that you get. What's beautiful about the Class D stuff that's so different from working with the tubes or the transistors is, in a nutshell, everything is knowable. you can mathematically work out everything that's going to be there, and it will do what the math says. You run into stuff with tubes where you have variances and weird peculiarities that don't show up in the spec books for the tubes, and so you have to gain some experience working with this stuff to know what's going to work and what isn't. The Class D is a little bit different in that regard. Ultimately, we started out building zero feedback stuff because you could do that. But it turns out we felt that going with a self-oscillating circuit would probably work out better. We were making pretty good progress with the zero feedback stuff, but what we ran into there is that the Class D amp has to switch on and off at a certain speed, and to do that, traditionally, the simpler way you might do it would be use a triangle wave oscillator as to set your switching frequency. And we found that you really had to lock that frequency down, because if it drifted back and forth at all, the amp it would manifest as noise, and the noise was quite unpleasant. We did a lot of experimentation and iterations, prototypes, trying to reduce the noise. We made a lot of progress. Finally decided, you know what, we're going to go with a self-oscillating deal. Now, in the self-oscillating, what you do is you put a lot of feedback on the amp. Now, you may recall, I'm an OTL manufacturer, and one of the OTLs that we were, that was the prior art, was an amp known as the Futterman. And the Futterman ran a lot of feedback. It was a 60 dB. And we'll have a little conversation about that in a second. But it was supposed to be 60 dB. And the thing was, if you didn't set that amp up right, it could go into oscillation very, very easily. And Julius Futterman didn't always talk about everything that was required to keep the amplifier behaving, but he was putting little ferrite beads and stuff in his circuits to knock out to limit the bandwidth of the feedback loop. The way it goes into oscillation is you have something called phase margin, and that is simply that over the frequency response of the amplifier, at some high frequency point, the phase begins to shift relative to the input, such that instead of being negative feedback, the phase can shift so far that it becomes positive feedback. And if something sets it off at that frequency, the amp will oscillate, and you just have to shut it down. Well, in a Class D, what you do is you exceed that phase margin on purpose. The amp, you turn it on, it goes into oscillation, and there's your switching frequency. So then you have your feedback loop has to be designed to maintain that frequency and keep it pretty tight. And so you have a fairly sophisticated formula that Bruno Putzis worked out quite a while ago, called the oscillation criteria, and it's got 7 variables in it. And that one's a bit of a trick to work out. So anyway, but the beauty of it is you wind up with a very simple circuit. And the amplifier basically becomes very stable because you can't put it on some kind of load that'll make it oscillate. It's already oscillating. So that part was pretty neat. And of course, now you're running a great deal of feedback. And the advantage of that is twofold. First off, the switching of the output section can generate high frequency noise, but it doesn't generate outright audible distortion so much. The only thing that you wind up with is that you have to deal with the fact that the output devices switch on, and when they switch off, they take a little bit of time before they completely turn off. So you have to wait before you can turn the other device on to switch in the other direction. That period of waiting is called dead time, and that introduces distortion. It's not inherent to the output devices. It's a process that prevents them from blowing up. Otherwise, current can shoot through from one device to the other and heat them up very quickly, and that can damage the device over a very short period of time. So you have the shoot through current and the dead time associated. But otherwise, the output section isn't going to make any distortion of its own. So it doesn't have an inherent characteristic distortion signature like a traditional solid state or tube amplifier might. And of course, now we're running 35 decibels of feedback, and it's not just at 100 cycles. It's also at 1,000 cycles, and it's at 10,000 cycles. And so the distortion signature is linear. It's the same at all frequencies. That is fundamentally different from something like the Futterman, which has 60 dB of feedback at 100 cycles per second, but has considerably less at 10 kilohertz. And the reason for this is that you have a characteristic that all amplifying circuits have, which is called gain bandwidth product. And this is a product of the gain of the amp without any feedback, and its bandwidth without any feedback. And you know, this has been an ongoing thing in op amps going on for the last 50 years. Op amps made in the 1960s had very poor gain bandwidth product, and you know, that's been something that they've been working on, and now op amps made in the last 20 years have gotten so good that you can actually get them to do about 20 decibels of gain, and they can be exceedingly neutral as long as you don't go above that. The gain bandwidth product prevents you from having, say, 50 dB of gain if you want to cover the entire audio frequency. To describe this, let's put it this way. As the amplifier might have a certain amount of feedback at 100 cycles per second, its distortion will be at a certain level. And then when it runs out of gain bandwidth product, the distortion will take off and go like this. And so you have higher distortion at higher frequencies because there's less feedback. And we've all heard this for the last 50 years. You put the feedback in the amp, it gets bright and harsh. This is one of the reasons why it happens. In addition to the fact that the feedback adds the distortion I talked about earlier, it also is less than what you think it is at these higher frequencies. So the advantage of a Class D amplifier is it allows you to get around that. So you can have the same feedback at 15 kilohertz as you do at 100 cycles per second. And now the harshness and brightness is controlled because and with 35 dB of feedback, you've got enough feedback that now you can clean up all that those higher ordered harmonics that the feedback would otherwise cause if it was a lesser value. So the result is that a Class D amplifier does have the ability to be extremely neutral. And this is what I mean, people have talked to me over the last 40 years I've been doing this. I've, you know, told them, you know, if I could do this with transistors, I would do it in a heartbeat. Because the tubes are hot. People complain about the fact that they're hot. You have to replace them. There's variances from tube to tube, and boy, if you didn't have to do that, if you just turn it on and it would be amazing right away, that would be great. And so now I feel like we've actually gotten to that point, and Class D is what's brought it. So anyway, I guess without much more, I'll just show you what we got here. So I'm gonna unplug my phone from the charger. And here's my system. I got the classic audio loudspeaker T3. It's got a 15-inch woofer here and one that's down firing on the bottom. a beryllium diaphragm that's field coil powered by this this little power supply right here. And there's one of the Class D amps. I've got the cover off. This is the output module here. And right down here, we've got our GaN FETs here and here. And as you can see, well, this is all surface mount. You can't do this point to point and with through hole stuff. This is our power supply. We've got protection circuitry and some regulators in here. And it's powered by a traditional toroid balanced input or single-ended. So that's the deal. So it's monoblocks. I got one for the other channel. And that's what our little Class D prototype looks like. This back in, so I don't kill the battery on this. So anyway, that's it in this system. Because these speakers are 16 ohms, the amp only makes 50 watts. But I can't run it out of gas in this room. There's no way. So that's yes. And the question I saw there, yes, those are GaN FETs. So that's gallium nitride device. And they are super fast. They can switch at 50 megahertz, no problem. We're not switching anywhere near that. We're more like 500 kilohertz. But we've had to really jump through a lot of hoops to ensure that we don't generate any noise at frequencies that high. Because if you do have noise like that that crops up, the output devices can switch at that speed and they'll just heat up. So we're mainly interested in keeping the temperature down at this point. So that's basically what my comments about Class D are right there.
Price?
There's a question. What is the price? We figured this set of amplifiers about $5,400 for the pair. So they're not crazy money. We really, I've wanted all of our stuff to be not crazy money. The speakers are made by Classic Audio, loudspeakers of Brighton, Michigan. They're the Model T3. This is an older set. I had them updated with the new crossover and the new drivers, but I've retained the original JBL horn. He's got a machined wood horn that he uses on the T3 that's a little bit better response. But you know, it's a fabulous speaker, and this particular set is flat to 20 cycles per second, and about 98 dB, 1 watt, 1 meter. So you know, it's what a lot of people would say. Well, that's great for a tube amplifier, and yeah, it is. But guess what? It's also great for something like this.
Any I mean, obviously you pretty much focused on 2-channel audio for the most part, as far as I know, at least from your history. With the Class D now coming into your kind of product line, any thoughts about going into multi-channel amps or anything like that?
When you're ready, come on up for dinner, please.
Okay, first off, Tony, am I still on the air?
You are, yeah.
Okay, all right. Because all right, we're thinking we'll probably start with an integrated amplifier. If we're going to do anything more than that, we haven't really discussed it yet. You know, it's a big enough deal for a smaller company like us to produce something like this. You know, because you know, you submit a drawing to a sheet metal company for the chassis, and you know, these days 10 weeks is very common. So stuff moves at just a glacial pace. So you know, some multi-channel thing, I honestly I don't feel the enthusiasm for it personally. We've got our hands full doing what we're doing right now.
Sure. you mentioned early on that people know you as an OTL company, but you're much more than that.
I would say we're much more about balanced line operation than we are. I just think, I mean, I run my own recording studio. I've been doing live recordings. I used to do a business on the side where I would take a refurbished Ampex 350 transport with 351 electronics, and I would do on-location recordings using 2 microphones. I know the balance line stuff works. I've worked with it for decades at this point. It's got what audiophiles have always craved, which is absolute neutrality. And anybody questioning that has to look at their own recording collection of classical and jazz made in the 50s and 60s. I mean, all that stuff was done with balanced line connections. You'd think that you'd start hearing the colorations of the cables at some point, but the better you get your system, the better those recordings sound. Because even back then, the Neumann U67 and the Telefunken mics and stuff, those were amazing elements that they devised for those microphones. I've got a set of U67s, and man, it's a fabulous, fabulous microphone. When you're wearing your headphones, those microphones are so good, and the mic electronics are so good that they can fool you into thinking that what you're hearing on the headphones is actually real. I remember one time I was doing an on-location recording, and I used a set of RCA ribbon mics, and there were 2 audiophiles that wanted to come with me, local guys. And so I set up the recorder in the back room. I was recording a choir, and it was in this beautiful stone cathedral that's actually only about a mile from here on the College of St. Catherine campus. Gorgeous cathedral, and the choir sound was spectacular, and I just really wanted to capture this. And so we had everything set up. It was all running, and one of the guys was listening to the mic feed, and I said to him, look, I want to move the microphones back about 4 feet. Now, ribbon microphones are very sensitive. You have to be very careful with them. And so, I was going to move them gently. But I went through the door out across the stage, and I walked up to the mic stands, and I was going to pick him up. Well, this guy's wearing headphones, and I wanted to warn him that, I'm going to move the mic stands now. So I just looked up at the mic stands. I said, okay, I'm going to move the mic stands now. I picked them up and moved them. And then I came in through the side doors back to the backstage area, and that guy was white as a ghost. And the other guy was laughing his butt off. And I said, what happened? And he said, he saw you go through the door. And then we know that the other door, if you go through there, is a big clunk when the door shuts. And he saw you go through the door, and then a few seconds later, he heard you standing behind him, didn't know how you got there, and just spun around, and there's no one there. And that's, believe it or not, that's what audiophiles are actually after. But when it's rare when it happens, but I've had the experience of been listening to my system, and suddenly I realized there's somebody in my room that's singing along with my stereo. And, I looked, and there's like no one there. And, that's, as spooky as that is, that's actually what we're after. But, this lesson and other similar things like that taught me a long time ago that the mics and the microphone preamps and the headphones, they have arrived at that point where the spookiness is there. It's when you put the recording into some kind of media and then play it back, that's where you get in trouble. That's where most of it comes from. But anyway, I thought I'd offer that little anecdote as part of that. And now I've forgotten the question.
Actually, there was a couple other questions earlier on. We're kind of closing down towards maybe the end here where we can just maybe open it up. But someone had asked, you mentioned you played in an orchestra. What instrument did you play?
String bass.
String bass. Okay.
Yep.
And I know that you played in a progressive a rock band. I actually have one of your recordings, and you're gracious enough to sign it for me. Keyboards, right?
Yeah.
Yeah. Okay. Any other? I mean, you mentioned harpsichord and piano at an early age.
Well, you know, I took an interest in analog synthesizers quite a while ago, and so most of the synthesizers I have, I found them derelict and refurbished them and got them running. I've got a Prophet 5 EML 101 Moog, you know, just a mini Moog Model D, and I picked up a Mellotron, which is a keyboard that when you play a key, it actually engages a pinch roller against a capstan, and it plays a tape recording of that particular instrument playing the note that you want. And so the keyboard's about this wide. And, you know, so the basic string tape set you get with it is a violin, flute, and cello. So by flipping it, there's a lever that moves the tape head back and forth to pick up the different one of 3 tracks that's on each tape for each note. So, you know, I played all these instruments with my band, and, you know, we were one of the very few bands in town for years that had any more than 3 people playing in it, you know, where we were actually doing gigs with the Mellotron on stage. So, you know, and I have a few recordings of Native American flutes as well.
I guess I'll ask one last question, and then I think we could probably open it up and people can chime in with their other questions or comments. You know, obviously, you know, you've talked to me about this, about Class D, and we've now heard you talk about, you know, where you're going with that. Any other technologies kind of tickling your funny bone, getting you interested, you know, things that, you know, you're reading about or hearing about?
I'll tell you, you know, this is going to sound a little weird, but, you know, the word enthusiasm comes from a Greek word to be filled with God. And I just love that idea. About a year ago, I got real enthusiastic about coming up with more of a personal stereo. In this case, something for the desktop, or maybe a bedroom system or something like that. And so I designed and built a little 5-watt per channel stereo amp, and it turned out really well, and it was a lot of fun. My goal was, I had, you know, this is part of my nostalgia from working at the old Allied Radio service department. I had purchased they made a matching amp and preamp, and the integrated amp was about this wide and about this deep, about that tall, and they made in wood cases a matching tuner for it that had a kind of a rotary dial like the Advent receiver, and you know, it made 5 watts per channel. It had bass and treble controls, and actually had a moving magnet phono input on it. Just a real basic low-powered amp that they sold cheap. And I picked up both of them and refurbished them. But after a while, and it was early 70s, so this thing, it was one of the smoother solid-state amps you could get at the time, because it made a fair amount of second-ordered harmonic distortion until you pushed it to full power, where then it you know, it clipped like a traditional solid state amp. But it was very smooth sounding. It didn't play bass real well because there were just too many coupling caps and weird timing constants in the circuit. It was very, very simple transistor circuit. But I refurbished it and I ran it in my bedroom system for a while. And after a while, I thought, I bet I can do better if I build a little tube amp for that. And I looked around and I found this this little power tube about this big called an EL95. A pair of them in push-pull is only good for about 5 watts. And one of the things is that I didn't want to put a single-ended triode amp in this deal. The thing is, if you've got a good quality single-ended triode amp, even one that makes only 5 watts, it's a fairly sizable piece. And you know, the amp, the tube is, you're going to get some heat out of that whole thing. And I just thought I could do better. And one of the things I've learned in the last 15 years in particular is that the distortion signature of the amplifiers is the sonic signature of the amplifier. When you listen to all these different amps and go, okay, this one's a little brighter, this one's got this or that or the other thing, you are describing the differences in the distortion signature of these various amplifiers. And it turns out that the second harmonic and the third harmonic are very important in a tube amplifier for masking the presence of the higher orders. This may come as a surprise to a lot of people, but the single-ended triode amps makes more higher ordered harmonics, which the ear senses as harshness and brightness, than any solid state amp. But they have so much second and third that they mask the presence of those, and so they sound smooth and sweet. It's not until you push them over about 20–25% of full power that these higher ordered harmonics start to show up a little bit more, and your ear uses them as loudness cues. And so since your music is very transient in nature, the loudness cues are literally showing up on the transients themselves, giving these amplifiers very dynamic quality. And this is one example of how the distortion signature interacts with the physiological nature of our ears. Well, you can take advantage of that in other ways too. And for example, this little transistor amp sound very smooth because it made a second order and it masked the higher order stuff. So it's okay, but it just didn't play bass. And so I designed this little amp with the EL95s. And I looked around a little bit and I found a fairly nice designed output transformer I could buy. It wasn't off the shelf. I had to wait 6 months to get the darn things. But it was ultra linear. And so I had a push-pull output that was ultra linear. And I wanted to have the third harmonic be the predominant distortion rather than the second. And the reason for this is that there's 2 different distortion signatures that are commonly heard in tube amplifiers. The single-ended triode has what you might call a quadratic nonlinearity in mathematical terms. And that starts out with your second is way high, and then you get your third and the fourth, and it kind of drops off like this on an exponential decay. And that's what you need to have so that the higher orders are masked. Well, if you start with the third as the predominant distortion, and you can do this by having a completely differential push-pull circuit from input to output, canceling all the even orders through the amp, not just at the output, but all the way through, then the third harmonic predominates, and it'll predominate at an order that's less than seen in the single-ended triode amp. So if the single-ended triode amp has a second here and the third is down here, push-pull amp will start with that third about there, and the succeeding harmonics will drop off at a faster rate. And this is because the even orders are being canceled throughout the circuit, and so you're not compounding distortion as much from one stage to another. Well, in this case, the little EL95 was meant to be easy to drive, so all I needed was one 12AT7 built in as a differential amp, which is a way of making that circuit be push-pull. But differential means that if you push one tube to run hard, that'll force the other tube to turn off. And if you force the first tube to turn off, that'll force the other tube to turn on. And it's because their cathodes are coupled together. Well, I just did the best I could to design that circuit to drive this little ultra linear output. and it worked beautifully. I got a beautiful third harmonic with the proper cubic, the third harmonic being predominant means that you've got what's called a cubic nonlinearity as opposed to quadratic that I mentioned earlier. And it falls off on an exponential rate that's higher. And so you get less of the higher ordered harmonics. It's a smoother sounding amplifier. And because there's less distortion, it's more transparent. And, the other impetus for me doing this is I had a 2A3 based single inner triode amp, and I played with it for a while. And then someone gave me a type 45 single inner triode amp, and I had said, well, what happens if you do this push-pull? And I made a type 45 push-pull amp. And right away, it sounded better than it ever had, either the 2A3 or the type 45 running single inner triode. And I realized that when people are comparing single inner triodes and saying they sound so much better than these push-pull amps, they're not comparing apples to apples. They take the single inner triode and they compare it to maybe a 35-watt push-pull amp. And that 35-watt push-pull amp has a push-pull output, but a single-ended input. And when you mix those two topologies, you algebraically boost the fifth harmonic a little bit. And that's what the single inner triode guys are objecting to. And if you ask me, you either do it fully differential from input to output, or you do it single-ended from input to output, and you don't mix the two topologies inside one amplifier, because you will get this. And this should not be a secret. Norman Crowhurst was writing about this a good 50 years ago, 60 years ago. So, and the stuff I talked about feedback, he was writing about that back then too. So none of what I'm saying here should be controversial in any way. But anyway, this little amp worked out, and I thought, okay, it's got a little bit too much gain, and I just ran the feedback on it to just knock the gain down and do nothing else. And I think if you don't have enough gain bandwidth product in an amplifier, and you're not going to get that with a tube, that is the only way to run feedback, is that it's already linear and musically listenable already, and then use the feedback just to control gain and nothing else. That way is your best avenue to use it in a circumstance like that. Anyway, that amp worked out pretty well, and I made it physically the size of this little solid state amp I was talking about. It fits with room to spare on a sheet of notebook paper. So I haven't done anything with the Korg tube, but it looks like fun though. Nelson Pass did something with that. Anyway, I've been using this little EL95 amp in my bedroom system for the last year, and it's given me a surprising amount of satisfaction. I use it with a single sub that I had to just move around the room until I could actually hear it without the standing waves canceling at the listening position. And I wanted an amp that couldn't get in trouble if I fell asleep listening to it, and it works great for that. So anyway, that's been one of the little projects I've been working on. Beyond this, I think after we feel established with the Class D amp, we'll probably work on a stereo integrated amp to go with that. So I'm sorry I sound so roundabout and just go on blathering, but you said this might be two hours long.
Well, I think at this point we can maybe let people get off mute and talk to you and ask you some questions directly. I know we've been monitoring them in the chat. I hope I covered most of them. If I missed you, I apologize. Maybe you can take yourself off mute and ask Ralph directly if we did.
Anthony, this is Bruce. Yeah, the one question I had again was on the spatial clues. Which is better, or which is more important, or does more clues, the preamp or the amplifier?
I'm going to go with preamp every time, and it's just because if the preamp gets it right and it's got all the spatial information intact from the recording, your chances of that being reproduced by a easy amplifier are a lot better than if you have a really great amplifier and the preamp is unable to get it right. So it's always got to start upstream. You can't solve problems downstream.
Thank you.
Oh yeah. Someone asked about the tube versus solid state, and I'll tell you what, if you can make a solid state be neutral, I've got absolutely no reason why that wouldn't be a problem. I'm not, although I've been doing tubes for the last nearly 50 years, the simple fact of the matter is I'm completely open to solid state, and I have been the whole time. The problem is we have seen the technology change over the last 50 years. What was possible now was not possible with semiconductors 50 years ago. When I first started, the 2 and 3055 was king, okay, as power transistors. And, I've got an LP mastering system, the Westrex 1700 electronics, and they were designed to be state of the art. And oh my God, the semiconductors that they had to work with back then were just terrible. And nobody in their right mind would try to design an amplifier with that stuff now. So that's part of what this is about. You can make a semiconductor preamplifier be very, very neutral and correct if you know what you're doing.
Looks like we had a question about hybrid amplifiers and your thoughts on that with looks like tube input and tube VAS, but maybe a MOSFET output or in a source follower mode.
If you're doing that as a power amplifier, you can't get you'd better know what you're doing, because the upshot of it is you really, really need to get that gain bandwidth product. If you don't have it, you won't be able to run enough feedback to get this thing to work. You see what I'm saying? And that's what the issue is. I mean, at that point, you've got to run zero feedback, or, and deal with what that means in terms of your output impedance. So with the MOSFETs, you have a better chance of the output impedance being pretty low, but boy, you better find the right devices and massage them properly and all their operating points in order to get good linearity out of it. Does that answer the question?
It came from Dennis, so I'll let him either type it in or speak.
Okay. So many people, if they're running feedback in the amplifier, I do have a strong opinion about that, which is the circuit had better damn well have the gain bandwidth product. There are a few traditional solid state amps out now that actually do that. Their distortion product at 100 cycles is not significantly different from what it is at 10 kilohertz. And that's the thing, is one of the beefs I've had about the test and measurement regimes we've been seeing over the last 50 years, is that spec sheet that you get with the amplifier doesn't show you all the specs you need to see. And the important one is distortion versus frequency. I didn't catch that last question.
Yeah, let's this is a good one, because I had something that I wanted to talk about on this too, but looks like someone has a question on a balanced DVD player direct to solid state power amp. Could a preamp better that in any circumstance?
If the DVD player has the ability to drive the interconnect cable properly, and the balanced output is supporting the AES 48, that should work fine. Okay, if it doesn't, you'll need a preamp that does. And that's one of the things that we sell a good number of our preamps as line stages, simply for that reason, that there's so many digital products out there, despite the fact that they have plenty of output to drive a power amplifier, they can't drive the interconnect cable.
Right. So then I think I've seen you actually speak about this. You're popular on the Audio Gone forums. I know you moderate the forum over on Audio Asylum. So obviously you spend some time talking with audiophiles online and DIY folks and some other technical folks. But you always had a theory of the 4 points that a preamplifier serves in a system. Oh, yeah. And maybe you can talk to people about that. So I think that'll be of interest.
People know most of them. It has to control volume. You've got to be able to select your input, right? And provide any needed gain to deal with the various inputs that you have, okay? And this is why passive won't always work, because you may need to add gain if you've got a phonosection, or if you've got a tuner, or if you've got some older consumer gear like a cassette deck or a consumer reel-to-reel. The fourth thing that a preamp really needs to be able to do is it's got to control the interconnect cable at the output of the preamp that goes to the power amplifier. Some preamps are better at that, and you'll find that the interconnect cable seems to make less difference in the system because of that preamp. A balanced line preamp that supports AES-48, you're not going to hear differences between the cable, and nothing to write home about. And as a little anecdote, we had a customer on the west side of town here. He had an all NDL system that was all balanced setup. But the stuff didn't support AES-48. And I got to bring my preamp over. And, the guy said, well, look, Ralph, I'm 70 years old. I don't want to be crawling around hooking all this stuff up. And he had some really expensive, very stiff balance line cable that was $1,000 a foot. He had 24 feet of it. Wow. Okay. And, I said, look, Dave, if this is any kind of issue, just use my cable. And if it doesn't sound as good, don't buy it. Okay. And, the cable that I brought was Mogami Neglex. It's just a good quality recording studio cable. It's not expensive. Next day he calls me up and he bought it because it sounded better than what he had. And, I think he sold that balanced cable for, I'm sure he got at least 50%, knowing him, of what he paid for it, which means that just on the sale of cable alone, at the time, he was able to buy the preamp and the cables I gave him and have a better sounding system to boot. That's how important the balanced line system is. You don't have to have expensive cables. You have to support the system. But once you do, it's an exotic cable system that works. And why audiophiles have so much trouble understanding this, I think, has to do with the Veblen effect, which is the idea that, you spend a lot of money on this thing, therefore it should be greater value also. And that's not true. And because it's not true, a lot of manufacturers will, but the perception is there, a lot of manufacturers will simply raise their price and people will buy it because they think they're getting greater value. And if you're into bicycling, here's another little anecdote. There was a company called Sun Tour that made derailleurs back in the 1970s. Mm-hmm. And they were tested and found to shift better, faster, and more accurately in every way than Shimano or Campanola at the time. And but the thing is, Sun Tour sold those to a formula rather than what the market would bear. And so these derailleurs were showing up on fairly inexpensive bicycle boom bikes, and nobody thought they were that great because Campanola couldn't be pushed out of its perch because of the Veblen effect. The Sun Tour kind of didn't play their cards right, but basically when you're pricing to a formula rather than a perceived value, the equipment will be the same performance or better for a lot less money. So I've always been a fan of just, we're pricing it to a formula. Who cares what it sounds like, as long as it says what we say it does. Any other questions?
Yep. Any other questions here for Ralph? Otherwise, Larry or Leslie could take it over.
Yeah, I have one more. What is your, audition policy for your amplifiers and your preamplifiers?
Oh, we do have an audition policy, and this is basically how it works. Most of the time we're back. And so you basically have to buy it from us. And if you like it, you keep it. And if you don't, you've got 2 weeks to audition it. If you've decided to return it, you've got to get back to us in the condition that we sent it to you, and at that point, you're out the cost of shipping. So
Yeah.
that's how it works. Otherwise, talk to one of our dealers.
Looks like we have a kit question. Any kits still available?
Nope, we got rid of the kit. I hate to put it this way, but we wound up, we had a pretty intense manual, and you followed it note by note, you would wind up with a functioning amplifier. But we wound up spending far too much time hand holding for that. And since the pandemic, the sales have gone off the charts, and we just, I hate to say it, but we just don't have the time to be able to handle that anymore.
Looks like
Well, I think we had well, there was a couple questions in the chat about, I think we want to be able to hear your equipment. Dealers in the Bay Area, are you going to be at any shows?
Our next show that we think we're going to be at, where I will be there, is probably the Expona show. We're going to have some representation at the Tampa show, but that's just in like 2.5 weeks. And honestly, I guess my concern is Omicron at that point. So somebody's got a question here.
The question I have is, you had mentioned that regarding speaker impedance, are there that many companies that are making 16 ohm speakers these days?
It's more common than it used to be.
Okay.
If you look for someone who's got a single inner triode and their speakers designed that single inner triodes can drive it, it's probably going to be a higher impedance speaker. Because anyone who's playing with single inner triodes has probably figured out, these things sound better when you use a 16 ohm tap. And there's a good reason for that too. If you use a 4 ohm tap with almost any output transformer, you can lose an octave of bandwidth off the bottom end. And
Wow.
Single inner triodes, bandwidth is the name of the game with them. That's why the smaller ones always sound better. Okay, I didn't get that one.
Oh, Jim had an interesting question. Did you see that
Uh-huh.
one? How can you tell if it's advertised as balanced, it's truly designed as such correctly?
Oh, ask the manufacturer if it supports AES 48. Sometimes you can see in the manufactured product that there's RCA outputs available in the side by side with the XLR outputs, and quite often that's a sign that it doesn't support AES 48. Because balanced and single inner are mutually incompatible. How are they able to do that? So, in a lot of cases, the answer is, well, it doesn't support AES 48. They've got two single inner outputs. One of them is inverted, the other is non-inverted. And they're saying, well, we're just going to hook this up to the XLR and that's okay. And it doesn't. AES 48 means Audio Engineering Society File 48. And it's basically the definitions that talk about how the grounding is handled and stuff like that, because that is what we're talking about. Balance line system ignores ground. The shield is not used for signal return. And what this means is, and I'll show you a little demonstration here. I'm going to go turn this amplifier on, and it's running balanced. Okay, so it's on right now. And you'll notice it didn't pop because we de-popped it. But here's the balanced input, and I got the amp on, and I just disconnected it. Okay, and there's the connection. I'm going to plug it back in. All right, and that's if you got what that is about, that didn't pop because the ground circuit isn't part of the audio signal. So I didn't break the circuit in such a way that the cable was able to act as an antenna. You see what the distinction there is? The shield is shield only. There's no audio, no circuit return path that's part of the shield. And so it very naturally is very stable in that regard. I've grown very used to unplugging cables live while the equipment's on, because with balanced line, you can do that.